4. Zeros are polynomials. So a real zero is a polynomial function of degree n can have at most n real zeros. That was part of your quiz, was how many zeros could you have and how many turning points could you have. And remember, the most zeros you could have is your degree. So if your degree is 5, the most zeros you can have is 5. All right, and so that's all it's saying here, is that you look at your degree, and that tells you the absolute most real zeros you can have. Now, they can be rational, they can be irrational. What I mean by that is you can have like an integer or a fraction, or you could have like a square root. So like if you had to use your quadratic formula to solve, that would be an example of an irrational if you had like a square root in your answer. But your real numbers can be rational or irrational. Then they talk about this theorem. Key concept here. If f is a polynomial function, and they give this polynomial function with a degree that's greater than or equal to 1, meaning it can't be a constant function, integer coefficients, and your leading coefficient is not 0, or your constant is not 0, then every rational zero has the form p over q. So what they're telling you is they are telling you that your zeros will be a factor of either your first number or your last number of your polynomial. That's how it works out. All right. List all possible rational zeros of this function. So this one's really simple. This example that they give us, the first one. What they're saying is look at the leading coefficient. So my leading coefficient here then is a 1. It's a 1. And my constant is a 1. That means that my zeros will always be factors of those two or the combination of them. So your factors are pretty much 1 and -1. And so those are my possible real zeros. Only. Those are only my real zeros. In fact, if you were to find your zeros, that means factor this guy and set it equal to 0, you'll find that your zeros are indeed both -1. -1 with a multiplicity of 2. All right. Look at the next one. For this one, my leading coefficient is 1. My constant is a 9. All right. My constant is a 9. So my factors of 1, well, that's 1 or -1. My factors of 9 are 1 is a factor. We've already accounted for that. 3 is a factor, or -3. You'll notice I'm accounting for both. 9 is a factor, and -9. And then it can also be a combination of those put together. Always the end over the beginning. So we're always going to look at my possibilities compared to the P over Q. So when they're talking about P, they're talking about my constant, and when we're talking about their Q, they're talking about leading coefficient. So that means that you could also put any of these over these. Now it's always 1, so we'll do some that where it isn't 1, and it'll be a little more obvious. But those are my all possible real zeros. So then how do I figure out what my real zeros are? If it's not factorable, so if you look at this guy, he's not factorable. Like even if I tried to do by grouping, it's not going to work. I can't factor by grouping. So how do I figure out if I have a 0? All right, how do I figure out if I have a 0? Well, what I'm basically going to do is I'm going to start with these, and I'm going to go through it and figure out if it is a factor. How do I know if it's a factor? Well, I know that my remainder should be a 0. Remember your last question on your quiz. Is it a factor? Yes or no? And all you did was you did synthetic and decided whether or not your remainder was a 0. So if it's a 0, then your remainder will be a 0. So I'm just going to do synthetic. 1, 4. What's my x squared? 0, -12, -9. Some of you need to pay attention. If it doesn't have a coefficient, you have to plug in a 0 for it. It started with x to the 4th. We had to do x to the 4th, x cubed, x squared, and x. And since there was no x squared, I had to put a 0 there. So I'm going to test my 1. Exactly how I do it. Add 1, multiply up, add down, multiply up, add down, multiply up, so on and so forth. He is not a 0. Why? My remainder is not 0, so this guy doesn't work. You actually, well, until you can get to a factoring point. So we're going to do it for the next guy. We're going to do it for -1.
So the answer is to A or what?
Just this one was factorable, so it was -1 with a multiplicity of 2. For this one, we're just going to continue to do synthetic. And there we go. So this guy is a factor. All right, this guy is a factor. And so typically for these, I will actually give you one. I'll want you to list all the options, and then I'll hand you one and say, okay, here, and I'll do the rest of them. All right, so that you're not doing this 47 times with them, these. And there will come a point where you can actually factor it. So like with this one, so I know that -1 is a 0 because I just proved it. All right, so I actually don't have to start back at the beginning up here. I can actually use this row, this row right here, and I can do synthetic going forward. I don't have to like start back at the beginning. And so I think the next one they did was -3. So you don't have to start back at the beginning when you do this. -3 is also a 0. And now I have, so I started with x to the 4th, right? This was x to the 4th. This guy would have been x cubed. So this guy is x squared, right? So x squared minus 3, I can actually factor. I can actually solve for that. X squared minus 3 equals 0. I can solve.
So we have to go through all of them.
Right, so it's going to be, yep, x squared minus 3. That's x squared equals 3. So x is going to be the positive or negative root of 3. So I'm going to get square root of 3 and negative square root of 3. My degree was 4, right? I have 1, 2, 3, 4 zeros. 2 of them are irrational. 2 of them are rational. Possibility should have been +1, -1, +2, and -2. All right? And then when you did this using 1, your x cubed was 1, your x squared was 5, your x was -4, and your constant was -2. And 1 was a factor there. And then if you looked at this guy, this is going to be x squared plus 6 plus 2. And it's not factorable, right? Because no factors of 2 add up to 6. And so even if you use your quadratic formula here, you're going to get an imaginary number. You should. So your only real 0 then is going to be the 1. That's your only real 0. These are all your possible. This is your only real 0 is 1. Which means, and we'll talk about it in the next section. This chapter we'll talk about the fact that there's only 1 real 0, so that means there's likely 2 imaginary zeros. So if you did quadratic formula, you would get 2 imaginary zeros. They would still add up to 3 zeros altogether, but only 1 real 1. So A and B had 1x squared or 1x cubed or 1x to the 4th, okay? You'll notice that this one has a leading coefficient of a 3, which means that instead of just looking at the 8, we're going to have to consider what happens if we put it over all the factors of 3 as well. All right, so we're going to look at all of our factors of 8. Well, that's going to be +1 and -1, right? That's going to be +2 and -2, +4 and -4, and +8 and -8. Those are all my factors of 8. Normally, we would only have to consider then the factors of 1. Well, all of those over 1 are still the same thing, right? But now we have to consider the factors of 3, all right? So the factors of 3, my factors of 3 are 1 and 3, right? So I have all of these numbers over 1. Well, that's all of those numbers, right? But then I have to consider, if it's going to let me select it, I have to consider all of these numbers then over my other factor of 3, which is 3. So I have to consider 1/3, -1/3, 2/3, -2/3, 4/3, -4/3, 8/3, -8/3. I will say list all the possible zeros. And so if I ask you to list all the possible zeros, then this guy right here would be a list of all possible zeros. And most honestly, when they do it, they'll normally say positive or -1, positive or -2, positive or -4, positive or -8. And then they'll say, okay, positive or -1/3, positive or 2/3, positive or negative 4/3, positive or negative 8/3. And so that will be one of your answers. Hey, just list all the possible ones.
Sorry, those things about them, like.
All right, so then I'll say, now that you've done that, here is one of the zeros. And in this case, like -2 is a 0, right? And so I'll say -2 is a 0, find the other ones. And so then you'll just have to do it once, and you can use quadratic formula or factoring to solve. All right, and so that's why I kind of want to make sure you know how to do the quadratic formula or the factoring, because I am going to hand you one of the zeros. I'm going to say, tell me all possible zeros. Here is one of them that actually works. Use synthetic division to simplify it some, and then find the rest of them. Okay, so your first part of this answer would be this list of zeros down here. So your first answer would be that list of zeros. And that would be the answer to the question. That would be like what you would tell me. Those zeros would be the answer to the question. And then I would say, okay, now that you have all of your possibilities of them, I want you to use the one that I give you and solve for the rest, okay? So then I would say one of the zeros, 1 0 is -2. And I would actually tell you that. And you would see, okay, yeah, well, that's one of my possibilities. I actually said -2 is a possibility. Now I'm going to use -2 in synthetic division because I just told you -2 is one of your zeros. So you're going to take the 0 that I give you, and you're going to use synthetic with that guy specifically. You're not going to go through and test every single one. I'm actually going to hand you one, okay? I'm going to hand you one. All right? And so this is going to be part of your answer. List all the possibilities, and then you're going to take the one I give you and do synthetic division. And so you're going to do it here, and you're going to say, okay, so we have -6, -13, +26, +4, -8, 0. We see that we have a 0, okay? And so I'm going to say, well, x equals -2. That's one of my zeros. All right, what are my other ones? So you're going to take this guy, 3. It started at a cubed, so we're going to say x squared minus 13x plus 4. Now, this guy is actually factorable, all right? So if you're good at factoring, factor him. If you're not, use quadratic formula, all right? Whichever one you want to do, they both work. If you're good at factoring, once again, factor it. So you can say 3 times 4 is 12. Factors of 12 that add up to 13. Well, that's 1 and 12. So I can say 3x squared minus 12x minus 1x, because that's what I'm doing here, plus 4 equals 0. How do I factor this guy? By what method? Factor by grouping. So I'm going to group this guy. Anytime you group after a negative, you change the last sign. What can I take out of 3x squared and 12x? 3x. I'm left with x minus 4. When you can't take anything out, just put a 1. And you're going to have x minus 4. So my factors are going to be x minus 4 equal to 0. And 3x minus 1 also equal to 0. So this guy is going to give me what is a 0? Where does x minus 4 equal 0? At 4. And then this guy, add 1 divided by 3, is going to be 1/3. You'll notice I had a 4 and I had a 1/3 as my possible zeros. My zeros are -2, 4, and 1/3. Those are my zeros. So your first answer is, what are all the possible? Your second answer is, here's a 0, find all of them. All right? Now, if you're not comfortable with factoring, let's say you don't like factoring, you need to memorize your quadratic formula. All right?
That's a squared, b squared minus c squared. Is that that?
That was Pythagorean theorem. Right? Negative b plus or minus the square root of b squared minus 4ac over 2a. All right? So like, I'm going to do the quadratic formula really quickly here. Negative b, that's this 13. So negative 13, that's 13. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right? And you're going to get 13 plus or minus. 13 squared is what, 169. 16 times 3 is what, 48 over 6. 169 minus 48 is 121, which is 11. So we're going to say 13 plus 11 over 6. 13 minus 11 over 6. 13 plus 11 is 24, divided by 6 is, lo and behold, 4. 13 minus 11 is 2 over 6, which reduces to 1/3. So either way, you're going to get the zeros that they gave you and the other two. All right? So all of your factors of 36 over 1, that's a factor of 2. What are your factors of 2? Your factors of 2, oh, that's not what I meant to do. Your factors of 2 are 1 and 2. So you put all of your factors of 36 over 1, well, that's that guy. And then all of your factors of 36 over 2. Some of them go back to what you've already listed. So like 1 over 2 is 1/2, but 2 over 2 is 1, and I've already listed 1. 3 over 2, that works. 4 over 2, however, is 2, so I'm not going to list it again. 6 over 2 is 3. I'm not going to list it again. 9 over 2, there we go. 12 over 2, I've already listed. 18 over 2, I've already listed. 36 over 2, I've already listed. So if it becomes something you already have, you don't have to list it again.
But if we do one,
Yeah, I mean, it's just redundant. So you could, but you need to reduce them. So you don't want to leave it as like 6 halves. Don't do that. Reduce it.
so it'll be 36 over 2 or...
That's 18, but I've already listed 18. You don't have to put it again.
Okay.
Does that make sense? You just have to list it once.
So if it equals up...
What do they mean by a zero, a real zero? What they mean is it's where you actually hit 0 on the graph, all right? So when your function equals 0, you're on the x-axis, right? So if you're on the x-axis, you're crossing, it's actually a 0 of a function is also the x-intercept of a function because you're touching the x-axis, okay? So they can call it a 0. They can call it an x-intercept. They're the same thing, all right? They're the same thing. And so they just tell you upper and lower bound test. It says if f is a polynomial function, you have real coefficients, a positive leading coefficient. Suppose you divide it, why do I keep erasing? Suppose you divide it by synthetic division. If c is less than 0, every number in the last of the division are non-negative, and the lower bound of real zeros. If it's greater than, it's non-negative, and then it's an upper bound. Lots of information there, all right? What they're telling you is that you can narrow down your search by deciding if, and basically this is just common sense. If you have something above the graph and then something else below the graph, somewhere in between there, you're going to have a 0. Well, that makes sense because if you start above the graph and you end up below the graph, you have to cross the graph to get to it if it's a continuous function. All right, and so that's all that key concept is trying to tell you there. All right, Descartes was a philosopher and a mathematician. I think they all went hand in hand years ago. All right, so he figured out that you can tell something about your zeros based on how your signs change. All right, the number of positive real zeros is equal to the number of variations in the sign. And then the number of negatives is the variations if you were to place all of your x's with a negative. All right, so let's just see how this works. Easier to show you than to try to explain the rule to you. So let's look at this function here. And what do they mean by variation? Okay, so what they mean is if I were to look at this, I start out as a negative and I move to a positive, right? Everybody see that? So that's one change. And then I go from positive to negative. That's another change, right? And then you'll notice negative to negative, that didn't change. So this is telling me that I have the potential to have 2 positive real zeros. So according to this, I'm going to have potentially 2 positive real zeros. And then what they do is they plug a negative in for the x, and they decide what happens then. So if I make this a negative, what happens if I take a negative times a negative times a negative, if I cube it? Does it stay negative or does it go positive? It's going to be negative, but then it's being multiplied by a -3. So what is that going to do here? This is going to become a positive 3x cubed. What about this guy? If I plug in a negative and square it, what's going to happen? Positive, and it's being multiplied by a positive 2. So there we go. What happens when I plug in a negative here? Right, because I have a negative in front. Negative times negative, that's become a positive. Is this going to change if I change my x's? No, because there is no x there. And then I am going to do the same thing here. Positive to positive, that is no change. All right? Positive to positive, that is no change. Positive to negative, that is one change. So I have one possible, or not possible, one negative real zero potentially. One negative real zero. That's what his rule tells you, okay? It's literally just counting. You're counting how many sign changes you have, given the function the way it is, and given if you replaced all your x's with negatives, okay? That's all you're doing with Descartes' rule of signs. You are just counting them up and saying, here's my possible positive, here's my possible negative. All right? Let's try one, and then we're going to do some factoring here. Let's look at this one together. All right. Possible real zeros, describe them. So let's do positive. Positive to positive. No. Is this a change?
Yes.
Yes. Is this a change?
No.
No. So I'm going to have one positive, potentially. All right? What happens when I plug in a negative here?
Yes.
It's negative, so this is going to be a negative, right? Negative here, this is going to stay a positive, right? Negative here, this is going to be a positive. This one will not change. That's going to stay a negative. So now we're going to count again. Negative to positive. Yes. Positive to positive. No. Positive to negative. So 2 negatives. That is all we are doing for Descartes' rule of signs. That's all we're doing. Sounds like a big word. Fundamental theorem of algebra. This is where we're going to get into it a little bit more, but the degree tells you how many zeros you have altogether. Positive, negative, real, irrational, imaginary. They will always be the number of the degree. So then what happens if they were to hand you the zeros? What can you do with it? Well, you can find your polynomial, all right? And so one thing I want you to know is that there are some that always comes in pairs. All right, if they give you a radical, let's say they say square root of 3 is one of your zeros, then you can assume that the negative square root of 3 is also one of your zeros. Because what happens? Well, how did they find that? Well, they found out that somehow by getting something like this, and they had to consider the positive and negative root. So anytime they give you a rational number as a root, you figure are an irrational, then you have to assume the negative is also true. It's also true of i's. What is I? I is the square root of what? Negative 1. So anytime they give you an I, you also have to consider that the negative of that could be the same. All right? Because I is also from a root. So you have the positive and negative root. All right? I want to do one without an I first because it gets very complicated with the I. So let's say from this function, they've given us these zeros right here, and they want us to find the polynomial. And so we talked about a little bit that if they give you irrational, like say they give you a square root, then you have to assume the positive and negative square root. And if they give you imaginary, you have to assume the positive and negative of the imaginary. All right, you have to assume the positive and the negative of the imaginary. So I'm going to get rid of this guy right here so we can do this particular problem. They have given us the zeros of negative 2, 4, and 3 minus I. Negative 2, 4, and 3 minus I. And so to find these, you're going to say x minus the negative 2. That's actually going to be what the factor is. X minus the 4, that's going to be a factor. X minus the 3 minus I, that's going to be a factor. And then we also have to consider the positive and negative piece of it. So we have to say x minus 3, and we have to do the opposite, plus I. The i's always come in pairs. So if they give you an I, you're going to have to assume a negative I. If they give you a negative I, you're going to have to assume a positive I. Okay? They always come in pairs because they're based off of a square root. That's why your irrationals, your square roots, also come in pairs because it's based off of a square root. So you have to consider the positive and negative root. And here, you are going to have to FOIL all of this. All right? So, make it as simple as possible. X minus a negative 2 is x plus 2. And I'll show you how to pair it up to make it a little easier. And x minus 4. All right? And I actually leave these alone because it ends up being sometimes easier to FOIL it when you leave them alone. So I FOIL this group here. And then I FOIL this group here. So let's do this together. All right. So this one's not bad. X times x is x squared. X times negative 4. Negative 4x. 2 times x. 2x. 2 times negative 4 is negative 8. And then, of course, we want to simplify that. X squared minus 2x minus 8. All right. Then let's do this guy. All right, so we have x times x, that is x squared. We have x times this group, the negative, so negative x times this group. Then we have x times this group, also the negative there, so negative x, 3 minus I. And then we have this group times this group, all right? These are conjugates of each other. Everybody see that? So we have 3 minus I times 3 plus I. Those are conjugates, right? It's a special case. It ends up being the first one squared, 9, minus the last one squared, I squared. What is I squared?
I squared is negative 1.
Right, so we have 9 minus negative 1. What's 9 minus negative 1? 10. So when we multiply these groups at the end here, we actually just get 10, right? Make sense? And then, of course, we can simplify this. So we can simplify this one a little bit. Distribute this guy. We get negative 3x, negative xi. And then again, distribute this. We get negative 3x, positive xi. What happens to that negative xi and positive xi? It cancels out. So that means that this group here is going to be x squared minus 3x, so minus 6x plus 10. All right? We're not done. So what do you think I need to do with those two groups if I'm trying to get a polynomial?
Not done.
Yeah, we have to FOIL this as well. So we're going to say x squared times x squared times negative 6x, x squared times 10, then negative 2x times x squared, negative 2x times negative 6x, negative 2x times 10, and then negative 8. So negative 8 times x squared, negative 8 times negative 6x, and negative 8 times 10. All right. And then just simplify it. Can anything simplify with the x to the 4th? No, it cannot. Cubed, we have a negative 6, a negative 2. So we have negative 8 for the cubed. For the squared, we have a positive 10x squared and a negative 8x squared. And I'm missing one, and a 12x squared. And so we're going to get 10 plus 12 minus 8. We're going to get 14x squared. And then we have a negative 20 and a positive 48. And then a negative 80. That given the 4 zeros, or the 4 factors, we ended up with a 4, if I had written it correctly here, in as my degree, okay? And so a 4, 3, 2, 1, 0, we have a 4 degree of 4, that's what we were looking for. I paired it up the neatest way I could. Anytime you have the grouping that is opposite, pair those up, pair the other ones up, and then FOIL from there. All right? So I want you to try one of these. It has a 0 of -3, a 0 of 1 with a multiplicity of 2. So how many 1s are you going to have? 2 of them. And then 4i. So you need to consider 4i and -4i. So altogether, you're going to have 5 zeros here. 5 zeros. All right? So go ahead and find your polynomial.